Question 1a. Work out the following. So part 1, 20 multiplied by 40. So I'm going to split this a little. 20 multiplied by 4 multiplied by 10. Because 4 multiplied by 10 is 40. 20 multiplied by 4 is 80. And then if I multiply it by that 10, 80 multiplied by 10 is 800. Part 2, 57 divided by 3. So I'm going to do 57 divided by 3 in bus stop method. I'm also going to write down some of my 3 times tables because it'll save my brain if I don't have to keep writing them out or thinking about them every time I divide a digit in this question. So 3's into 5 is 1, and the remainder to get from 3 to 5 is 2, so we're going to carry that remainder over. So now it's 3's into 27. 1, 2, 3, 4, 5, 6, 7, 8, 9. We landed exactly on 27, there's no remainder, so the answer is 19. Part 3, 2/5 of 30. So this is fractions of amounts. And when we're working with fractions of amounts, we divide by the bottom number. So 30 divided by 5 is 6. And then we multiply by the top. So 6 multiplied by 2 is 12. And that's our answer. 12 is 2/5 of 30. And we can check that's a reasonable answer because 2/5 is not a whole one, so we'd expect our answer to be lower than 30. Part 4, find 30% of 70. So I'm going to start by finding 10% of 70. So to find 10%, we divide by 10. So 70 divided by 10 is 7. So 7 is 10%. We want 30%. So we can multiply our 10% by 3. So if we multiply 7 by 3, we get an answer of 21. Again, that's a reasonable answer because we want 30% of 70. So that's less than the whole thing, and 21 is less than 70. Part 5, 1.03 add 12.8. So when we're adding decimals, we're going to pop them into a column, but it's really important that our decimal point matches up. So here we have 1s, but 12 is going to be written here so that the decimal point matches and all of these digits in these numbers are in the correct place value column. I've popped a placeholder 0 in there just to make me aware of that gap. So we're going to do 3 plus nothing is 3. 0 plus 8 is 8. We've got our decimal point in exactly the same place. 1 plus 2 is 3. 1 plus what would be a 0 here is 1. So our answer is 13.83. Part B, write 8% as a decimal. So 8% as a decimal. Well, as a fraction, it's 8 over 100. And if I'm dealing with the hundredths as a decimal, it's going to be 0.08 because that's tenths, hundredths. So this is my answer. Part C, in the box, write the smallest possible whole number to make the statement correct. So 4.4 is less than a particular number. So we're looking for the next whole number from 4.4. Well, the next whole number from 4.4 would be 5. And 4.4 is definitely less than 5. So we're going to pop that in our answer box. Question 2a. Most numbers have an even number of factors. For example, 10 has 4 factors, 1, 2, 5 and 10. 11 has 2 factors, 1 and 11. There is one number between 13 and 19 that has an odd number of factors. Find this number and write down all the factors of this number. Okay, so numbers between 13 and 19 then. We're working with 14, 15, 16, 17 and 18. Okay, let's think about factors of numbers then. So for 14 we would have 1 and 14, 2 and 7. That's 4. So that's an even number of factors. So let's get rid of 14. 15 we would have 1 and 15, and then we would have 3 and 5. That's 4. So that's an even number of factors. Remember, we're looking for odd. 16, 1 and 16, 2 and 8, and then it would be 4 and 4, but we don't repeat a factor. So 1, 2, 3, 4, 5. So 16 has an odd number of factors. It could be that one, but let's double check the others just to make sure. 17 would be 1 and 17. That's 2. That's even. 18 would be 1 and 18. 2 and 9. 3 and 6. So that's got 6. It's even. So the number between 13 and 16 that has an odd number of factors is the number 16. And those factors are 1, 2, 4, 8 and 16. And it's because there's a repeated factor. And it's because it's a square number. Because for square numbers, we're always going to have two factors the same multiplied together. Part B. Write down the first 3 even multiples of 7. Okay, the first 3 even multiples of 7. So multiples are the times tables. So we're going to do our times tables for 7. So we have 7, 14, 21, 28, 35, 42, 49, 56, 63 and 70. So we want the first 3 even multiples. So 1, 2, 3, 14, 28 and 42. Part C. Linda says, when I round the number of pupils in my class to the nearest 5, the answer is 25. How many pupils could there be in her class? Write all the possible answers. Okay, so we're rounding to the nearest 5, okay, and the answer is 25. So the options we have here is we could have 23, 24, 25, 26 or 27. And the reason why we can have those, guys, if we think about it, is because we're rounding to the nearest 5. So if we put a little bit of a number line here, so if we've got 20, 25, 30, because we're dealing with the nearest 5, so we're going to look at multiples of 5. 23 would be over halfway between 20 and 25, which means it's closer to 25. 27 would be less than halfway between 25 and 30, which means it's closer to 25. However, if we had 22, for example, that would be less than halfway between these two, so it would be closer to 20 as the nearest 5. So 23, 24, 25, 26 and 27. Question 3. What percentage of the following shape is shaded? So the first thing I'm going to do is find the fraction of the shape that is shaded, and then I'm going to convert that to a percentage. So 1, 2, 3, 4, 4, 8, 12, 16, 20. So there are 20 equal parts in total, and I've got 8 of them shaded. So 8 out of 20 of those equal parts in that shape are shaded. I'm now going to convert that fraction to a percentage. So when we're working with percentages, we want to work out of 100. So I'm going to make the denominator of the fraction 100. So I'm making an equivalent fraction with the denominator of 100. So remember, when we're working with fractions, we scale up or we scale down. It's a multiplicative relationship to get equivalent fractions. So to get from 20 to 100, I will multiply by 5 because there are 5 20s in 100. So to find my new numerator, I need to do exactly the same to the top. So 8 times 5 is 40. So now I have a fraction that is 40 out of 100. Well, I know percentages are out of 100, so the percentage of this shape that is shaded is 40%. Question 4. A teacher asked a group of students to choose their favourite sandwich filling. The 5 options are cheese, chicken, ham, salad or tuna. Each student chooses one option. The table, so this table here, and the pictogram, which is here, each shows some of the results for the 5 fillings. Okay, so we've got some of the table filled out, some of the pictogram, but not everything. Part A, complete the key, the table and the pictogram. So we're going to read information off all of these things to complete them all fully. So we're completing the key, the table and the pictogram. Okay, so let's see what we have here. We need to know what the key represents to be able to fill out this pictogram to start off with, okay? And then we can also read chicken and ham from the pictogram to fill out the table. So I don't have any information for chicken. I don't have any information for ham. No information for cheese here that will help me. Salad. Okay, so salad is 1 student. And for salad in the pictogram, they've given us a quarter of a circle. So that quarter of a circle has got to be worth that 1 student. So if 1/4 is 1 student, then a full circle has 4 quarters. So that should be 4 students. That's the key completed. Okay, now we can use the key to help us fill out everything else. So we're going to start by finding out how many chicken and how many ham to complete the frequency table. So each full circle is worth 4. So this is 4, 4, and then this is half of a circle, so it's 2. 4 plus 4 is 8, plus 2 is 10. So I'm going to put 10 chicken in the frequency table. I'm going to do the same for ham. So each full circle is worth 4. So that's 4, 8, 12. So I'm going to put 12 in the frequency table for ham. So that's the frequency table complete. We now need to complete tuna and cheese in the pictogram. So it tells us here that there are 3 students for tuna, okay? 1 full circle is 4 students. We've only got 3, so we're going to need 3/4 of our circle. So I'm going to draw half a circle, which is 2, and then I'm going to draw the quarter of a circle for the 1. So I've got 3/4 of the circle there. It doesn't have to be a perfect drawing. It just has to look like you're trying for 3/4 of a circle, guys. So that's my 3 cheese. I now need to fill in tuna. So tuna is 6. So I can put 1 full circle, because that's 4, but I need another 2 for 6. Well, if a full circle's 4, half a circle is 2 students. So I'm going to draw half a circle there. So we've completed the key, the table, and the pictogram. Part B, what is the modal choice of sandwich filling? So we're dealing with averages here. So mode is the most common. So we're going to look at either our pictogram or our table and find out the choice of sandwich filling that students went with most often, okay, the most common ones. That would be the one that has the biggest frequency. Well, 12 is the biggest number there, so 12 students went for ham. So ham is the modal choice of sandwich filling. Question 5a. Lucy writes down the first 5 square numbers. Lucy chooses 2 square numbers that have a difference of 12. Which square numbers did Lucy choose? Okay, so let's do what Lucy did to start off with. Let's write the first 5 square numbers. So remember, a square number is the product that you get when you multiply a number by itself. So for example, 1 squared is 1 times 1, which is 1. Okay, so 1 is a square number. 2 squared is 2 times 2, which is 4. So 4 is the square number. 3 squared is 3 times 3, which is 9. So 9 is a square number. 4 squared is 4 times 4, which is 16. So 16 is a square number. And 5 squared is 5 times 5, which is 25. So 25 is the square number. So that's the first 5 square numbers. 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. So we're looking for 2 numbers that have a difference of 12. Okay? So 1 doesn't have a difference of 12 with anything, but I can spot that 4 and 16 have a difference of 12. So they're the 2 that I'm going to go with. We're going to go with 4 and 16. Part B. Mary adds 2 odd numbers together and gets an answer of 21. Could Mary's answer be correct? Yes, no, or we cannot tell, and you've got to give a reason for your answer. Okay, so I am going to say no, Mary's answer is not correct, okay? And the reason why it's not correct is I know that an odd number plus an odd number always makes an even number. All right? But 21 is an odd number. So I've given a reason, okay? But I'm just going to explain to you guys why. So if, for example, let's think of an odd number, 1. So if I was to go 21 take away 1, that leaves me with 20. 20 is an even number. If I was to pick the next odd number, so 3, 21 take away 3 is 18. So whenever you take an odd number from an odd number, you're going to get an even number. So an odd, add an odd is even, but 21 is odd. So that's why Mary is not correct. Part C, write the following values in ascending order. So ascending order means going up, okay? So we want them to go up. So we want them to go from smallest to greatest. So when we're ordering mixed numbers like this, so decimals and integers, we need to be really careful. So what I'm going to do is I'm going to write a column down here and I'm going to match everything up to the appropriate decimal places. So 3 is 3 whole ones. 0.3 would be 0.3. I'm lining that decimal point up, guys. 0.302, 0.35 and 0.8. It's really important when we're comparing numbers that we have everything in the correct place value columns, okay? So I'm going to look at this column first, okay? Everything in that ones or that units column is 0 apart from 3. So this is definitely going to be my greatest value. So I'm going to put 3 there as my greatest value and cross it off so I know that I've dealt with it. Now we're going to compare the numbers that are remaining. So in the ones, the units column, we've got 0. So everything matches. We can't do much there. In this column, we've got 3, 3, 3, 8. So this is all in the tenths column. So these 3 match in the tenths, but 8 is bigger. Okay, so 8 tenths is bigger. So 0.8 is going to go there. So let's get rid of that one. Now that we're comparing these, I'm going to make these numbers the same size with placeholder zeros because I need to be able to compare each column. So the tenths column matches, so we're going to move over to the hundredths column. So in the hundredths column, we've got a 0 and a 5. 5 is bigger than 0 and 0, so that would be the next biggest value. So that's 0.35. Now we're comparing the last two numbers. So they match in the units and the ones, they match in the tenths, they match in the hundreds. So we now need to compare the thousandths. So we've got 0 and 2. 2 is bigger than 0, so 0.302 will go there. And then 0.3 is the smallest value. Question 6a. 25 players in a rugby team voted for their player of the season. Part 1, the 3 nominations for player of the season were Ashton, Jamal and Oliver. So we've got Ashton, Jamal and Oliver. The frequency table shows the tally of the votes from 10 of the players. Okay, so 5, 4 and 1, 10 of the players so far. The remaining 15 votes are shown below. So these are the candidate that the other 15 people have voted for. Which player won the vote for player of the season? You must show all your working. So what we need to do here is put those 15 votes here into this tally chart, okay? And then we can look at the frequency. And the person with the highest frequency has the most number of votes, so they will have won and they will be player of the season. So let's go through this systematically. So Ashton, so put a tally in Ashton, cross him off. Oliver, Jamal. So here, remember the tally, we go 4 and then we cross through, we make a gate for 5. Oliver again. Oliver. Jamal. Oliver. Oliver. Jamal. Oliver. Ashton. Jamal. Oliver. Jamal. Jamal. Okay, so we're going to total up the tallies now. So 5 plus 2 is a frequency of 7. 5 plus 5 is a frequency of 10. And 5 plus 3 is 8. So there's a frequency of 8 for Oliver. And I'm just going to double check that I've not missed anyone out. So we have 25 players in total. 7 plus 10 plus 8. So that's 17 plus 8 is 25. I just wanted to check that I'd included everybody, that I'd not missed somebody out and messed up when I was doing that. Okay, so remember, the person that won the vote for player of the season has the highest number of votes. So the highest frequency, 10 is higher than 7 and 8. So Jamal won the vote. So we're going to put the player of the season is Jamal. It says show your working. You've shown your working. You've tallied. You've totaled the frequencies. You've even done a check to make sure we've included everybody. Part 2. What percentage of the 25 students voted for Oliver? Okay, so 8 out of 25 voted for Oliver. So I'm going to default to a fraction to start off with. But remember, we want it as a percentage. A percentage is out of 100. So I'm going to scale up my fraction to an equivalent fraction that has a denominator of 100. There are 4 25s in 100. So I would have multiplied by 4 here. I need to do the same to the numerator. So 8 multiplied by 4 is 32. So 32 out of 100 votes for Oliver. Percentages are out of 100, so I can write that as 32%. Part B. Some of the players in Lindsay's team have missed games because of injury. She writes a question to find out how many games they have missed. Here's the question. So Lindsay's question is, how many games have you missed this season due to injury? 0 to 2, 2 to 4, or 5 or more. And then the question is asking us to state one criticism of her question. So my criticism is that there's an overlap in the response boxes. Because if somebody missed 2 games, do they put their tick here or here? Because both of them include 2. So we're going to write that down. There is an overlap in the response boxes for anyone who missed 2 games. Question 7a. Robin has a scale drawing of his local park. The scale on the drawing is 1 centimetre represents 250 centimetres in real life. So every 1 centimetre on the drawing is 250 centimetres in real life. On the drawing, a flower bed is 6 centimetres long. What is the actual length of the flower bed? Write your answer in metres. So the first thing to notice here is they say write your answer in metres. Everything's in centimetres. So at some point we're going to need to convert from centimetres to metres. But to start off with, let's deal with finding out the actual length of the flower bed. So I'm going to draw myself a proportion table. We know how I enjoy these. So we're going to do the drawing and we're going to do the actual length. So the length in real life. So on the drawing, 1 centimetre represents 250 centimetres, okay? On this particular drawing, the flower bed is 6 centimetres. I'm going to remind myself here as well that we're in centimetres. So what I would do to convert this is scale up. So I would multiply by 6 here to get from 1 to 6, but I have to do the same on the other side. So I'm doing 250 multiplied by 6. 6 multiplied by 0 is 0. 6 multiplied by 5 is 30. So we're going to write the 0, carry the 3. 6 multiplied by 2 is 12. Add the 3 is 15. So it's 1,500 centimetres in real life. But we want our answer in metres. Okay, so 1 metre is 100 centimetres. So 1,500 centimetres divided by 100 is 15 metres. So the actual flower bed is 15 metres. Part B. Robin has 240 daffodils and 60 tulips. What fraction of these flowers are daffodils? Give your answer in its simplest form. Okay, so when we're dealing with fractions, remember the denominator is the total number of what we have. So we need the total number of flowers because it's what fraction of the flowers. So we've got 240 plus 60, which is 300. So we'll have a denominator of 300. They want to know what fraction of these flowers are daffodils. Well, 240 of them are daffodils. We need to give our answer in its simplest form, guys. That's the important thing. So you've potentially only got 1 mark here. So I know I can divide the numerator and denominator by 10, which gives me 24 over 30. I also know that 24 and 30 can be divided by 2 because they're even numbers. So 24 divided by 2 is 12, 30 divided by 2 is 15. Now I know that 12 and 15 are both in the 3 times tables. I'm going to divide by 3. 12 divided by 3 is 4, 15 divided by 3 is 5. So my final answer, nice and clearly, is 4/5 of those flowers are daffodils. Part C, some rose bushes are divided equally between 2 gardeners. Write this division as a ratio. So they're divided equally between 2 people. So if it's between 2, they get half of them each. Okay, so for example, if we had 10 rose bushes, each gardener would get 5. If we had 4 rose bushes, each gardener would get 2. If we only had 2 rose bushes, each gardener would get 1. So I'm going to write that as a ratio of 1 to 1. Question 8. A shop sells the same brand of lemonade in 2 different size bottles. So we can get 1000 millilitres for £2.50 or 300 millilitres for 81p. Which bottle is the better value for money? So we can select which bottle. You must show all your working out. So we're not going to select anything until we've done some working out, and we need to convert these to be equal amounts of lemonade so we can compare the cost. Okay, so I'm going to do a little table here for the big bottle. Okay, so that's millilitres and cost, and this is the bigger bottle. So 1000 millilitres is £2.50. And then I'm going to do a little table for the smaller bottle. So millilitres cost 300 millilitres is 81p. So 0.81 in pounds, because I want to be able to compare. We work in pence or pounds, it's whatever you're comfortable with. So I need to scale these up to have the same amount. So I'm going to scale up to 3000 because I can multiply this by 3 to make 3000 millilitres, and I can multiply this by 10 to make 3000 millilitres. Okay, when I multiply this side by 3, I need to multiply this side by 3, so that becomes £7.50. When I multiply this side by 10, I have to multiply this side by 10, which becomes £8.10. Okay, so we're going to look at these two value nows. We want the better value for money. So we've got them both here. For 3000 millilitres, it costs £7.50 in the bigger bottle. But for 3000 millilitres in the smaller bottle, it costs more. It costs £8.10. So the 1000 millilitre bottle is the better value. (9a). Solve. 6x equals 42. So remember, 6x is the same as 6 multiplied by x. To solve an equation, we're isolating the variable, so we want to get x on its own, so we need to do inverse operations. The inverse of multiplying by 6 would be to divide by 6. So 6 multiplied by x divided by 6 gives us x. We have to do the same to both sides to balance the equation. 42 divided by 6 is 7. Part B, calculate the value of 4y when y equals -12. So this is a substitution question. We know what y is equal to. We need to substitute it into the expression 4y to find out the value of the expression in total. So 4y is 4 times y. We know that y is -12, so we're doing 4 times -12. A positive times a negative gives us a negative, and 4 times 12 is 48. Part C, simplify. 5w, add 3, and then in brackets 6w, subtract 2. So the first thing I need to do is expand that bracket. So 5w plus, so I'm expanding the bracket, 3 multiplied by 6w, subtract 2. So 3 multiplied by 6w is 18w. 3 multiplied by -2, or positive multiplied by a negative is negative. 3 multiplied by 2 is 6. So this bracket can be written as 18W subtract 6. Now we're going to collect like terms. And by collect like terms, I mean put together anything that has exactly the same letter and exactly the same power, or anything that are just numbers. So we have 5W plus 18W. That plus tells us that we're adding. So 5W plus 18W. Well, 5 plus 18 is 23. So we have 23W subtract 6 as our simplified expression. Got nothing else to combine that subtract 6 with, so it stays as it is. D. A shirt has T buttons. Write down in terms of T the number of buttons on 8 shirts. So if there are T buttons on one shirt, the number of buttons on 8 shirts would be 8 times T. However, we'll know from looking at the previous questions, we don't need to write the multiplication symbol here. We can just write 8T as an expression for the number of buttons on 8 shirts. Question 10. Here is a number machine. So we have an input, then we subtract 3, then we multiply by 5, and then we have an output. Part A. The input is 10. What is the output? Okay, so we're starting with an input of 10. The first thing we do is subtract 3. So 10 subtract 3 is 7. Now we're at the number 7. Okay, the next thing we do is multiply by 5. So that's 7 multiplied by 5 is 35, and that gives us the output. So 35 is the output. Part B. The output is 55. What is the input? So when we're working from the output to the input, we're working backwards, so we have to do the opposite. So if we're starting with an output of 55, moving this way, instead of multiplying by 5, we're going to divide by 5, because division is the inverse of multiplication. So 55 divided by 5 is 11. So now 11 is the value that we're working with. And then once we're here with 11, we're going to move in this direction, but the inverse of subtracting 3 would be to add 3. So we're going to do 11 add 3, which gives us 14. So the input is 14. And you can check if you want to. So start with 14, take away 3 is 11, multiply by 5 is 55, and that's the output that we started with. Question 11. Adele and Lewis are shopping in a bakery. Part A. So we've got some information here. So we've got the price of bread rolls. So 98 pence each, or you can get a bag of 5 rolls for £4.50. Adele buys a bag of 5 rolls. How much money does she save compared to buying 5 rolls separately? So we need to compare the cost of buying 5 rolls separately with the cost of buying a bag of 5 rolls. So we're going to have to multiply 98 pence by 5. So 98 multiplied by 5, whichever multiplication method works for you. You might use grid method. I always tend to default to column method. So 5 multiplied by 8 is 40. So I'm going to put the 0, carry the 4. 5 multiplied by 9 is 45. Add the 4 is 49. So it's 490 pence for 5 rolls bought separately, but we're comparing in pounds. So 490 pence would be £4.90. So separately, it costs £4.90. But if I buy a bag of 5, it costs £4.50. Okay, we want to know how much she saves buying a bag of 5. So we're going to do £4.90, subtract £4.50. Making sure when we're working with decimals, we line up those place value columns correctly and the decimal point. 0 take away 0. 9 take away 5, 4 take away 4. So it's £0.40, which is 40 pence saved. Part B. Croissants cost 90p each. I'm going to use my yellow, then I want to use my pink. Croissants cost 90p each. Cinnamon whirls cost £1.25 each. Lewis buys 4 croissants and some cinnamon whirls. Lewis has £10. What is the greatest number of cinnamon whirls Lewis can buy? Show all your working out. Okay, so he's got £10. He's definitely buying 4 croissants. So let's find out the total cost for those 4 croissants. So we're going to do 90 pence times 4. 4 times 0 is 0. 4 times 9 is 36. So it's 360 pence for 4 croissants, which is £3.60. Okay, he has £10. So let's see how much he would have left from that £10 after he's bought those 4 croissants. So 0 take away 0, 0 take away 6. I can't do that and get a positive answer. So I'm going to have to borrow from the place value columns before. So if I borrow from here, it makes it 0 and that 10. If I borrow from here, it makes that 9, and then we move that over to make this 10. So 10 subtract 6 is 4. Line up our decimal points. 9 subtract 3 is 6. So he's got £6.40 of his £10 left after buying croissants. We want to see how many cinnamon whirls he can buy. So I'm going to count up in £1.25s, guys, and see how many he can get. So £1.25 plus £1.25. So that's 10, 15, £2.50. Okay, so that's for 2 cinnamon whirls. I can't spell cinnamon. So 2 cinnamon whirls. Okay, so if I add another £1.25, that's for 3 cinnamon whirls. Let's add another £1.25. That is for 4 cinnamon whirls. So we're aiming to get as close to £6.40 as we can. So let's add another. So that's 5 cinnamon whirls. So £6.25. We're not going to be able to add another £1.25 because we've only got £6.40 left. So I'm going to say he can buy 5 cinnamon whirls. Question 12. A wind turbine generates 390 units of electricity per hour. How many units of electricity will this turbine generate if it continues at this rate for 2 hours and 20 minutes? Okay, so when we're doing any kind of calculations with time, we have to convert our time when it's in hours and minutes to something more numerical. So it needs to be a decimal or it needs to be fractions. So what I'm going to do is I'm going to write 2 hours and 20 minutes as 2 hours and 20 minutes out of an hour. So that's 2 hours and 20 over 60, which I can simplify to 2 and 2, 6, which simplifies to 2 and a third. So it's 2 whole hours and 1/3 of an hour. So for each whole hour, it's 390 units. So for those 2 hours, it would be 390 plus 390. Which is 780. But I've also got that third of an hour. So I need a third of what it would generate. So I'm going to divide this by 3. So 3's into 3 is 1. 3's into 9 is 3. And 3's into 0 would be 0. Okay, so that's 130. So 780 for the 2 hours. And then 130 units of electricity for that 1/3. So we're going to add these two things together. So 780, 130. So that's 0. 11, 8, 910. So 910 units of electricity were generated in 2 hours and 20 minutes. Question 13a. Ben needs 90 bottles of water for an athletics event. Bottles of water are sold in packs of 8. He makes this calculation to find out the number of packs he needs. So he does 90 divided by 8 and then gets an answer of 11.25. He decides to buy 11 packs of water. Is Ben's decision correct? And we've got to give a reason for our answer. So let's think about this before we tick a box. Okay, so he needs 90 bottles of water, which means he needs 11.25 packs of 8. Okay, so he needs 11 whole packs and then part of a pack, so 1/4 of a pack. So if he buys 11 whole packs, he's not going to have enough water. You should really buy the next number up, which is 12. Okay, so I'm going to say no. And then I'm going to write a statement to the fact that Ben won't have enough water because of the 0.25. So Ben won't have enough water. He needs 12 packs because of the 0.25. Part B. Ben divides 90 bottles in the ratio 4:1. He says to work out the larger share, we should divide 90 by 4. Explain what's wrong with Ben's method. So, well, what's wrong with it is if we're sharing to a ratio, we total the ratio first, don't we? So we would do 4 plus 1 equals 5. Then we would do 90 divided by 5. Okay, which equals 18. So what's wrong with his method is he's dividing by the parts of the ratio, not the total ratio. Ben is not dividing by the total number of parts in the ratio. He should divide by 5, making it nice and clear for them. Question 14. The table shows some of the values of y equals 1 subtract 2x for a range of x values from -2 to 2 inclusive. So here's this table. So we've got our x values, and then we've got the solution. We get the y value that corresponds to that x value. So part A wants us to complete the table. So we're going to substitute these values in, 2, 1 and -1, to find out what their corresponding y value is. But we're substituting into this equation here. So y equals 1 minus 2 times x. So this time x is 2. So y is 1 minus 2 times 2, which is 4. 1 minus 4 is -3. So I'm going to put -3 there. I'm going to do the same with the x value of 1. So y equals 1 subtract 2 multiplied by 1, because I'm replacing the x with 1. 1 subtract 2 multiplied by 1 is 2. 1 subtract 2 is -1. And then I'm going to do the same with -1. Or we can look at this like a sequence because it's a linear graph, okay, guys? So to go from -3 to 1, we're adding 2. From -1 to 1, we're adding 2. So if I go this way and add 2, it should 1 plus 2 is 3, and then 3 plus 2 is 5. So I've completed the table. Part B, on the grid, draw the line y equals 1 subtract 2x for the values -2 to 2. So the grid is actually on the other page here. So I'm just going to fold this so we can see our values as well as draw our graph. Okay, hopefully, let's make it a little bit smaller. There we are. So we're going to plot these values onto this grid here, okay? So we're going to treat them as coordinates. We've got an x coordinate and a y coordinate. So we're going to go to -2 on the x and 5 on the y. So -2 on x and 5 on the y would be here. -1 on x and then 3 on y. So -1 and then 3. 0 on x and 1 on y. So 0, 1. 1 on the x, -1 on the y, and then 2 on the x and -3 on the y, so 2 and -3. And what we can see there is a form in a straight line, which is what we want because this is a linear graph in the form y equals mx plus c. Now, I'm drawing this in pen because I want you guys to see it nice and clearly on the video. However, you should do it in pencil just in case you make a mistake. So we've answered part B. What's really important is we've plotted those points and we've drawn a straight line through it. If you don't draw that straight line through it, you're going to lose a mark, guys. Question 15. A bag contains 100 identically sized coloured balls. A ball is selected at random. The table shows the probability of choosing a blue ball, red ball or green ball. So the probability of choosing a blue is 0.42, probability of red is 0.3, and the probability of green is 0.18. Show, so we've got to show some working out here, guys, that the bag must contain 10 balls that are not blue, red or green. Okay, so if they're not blue, red or green, I need to find out what the probability of them not being blue, red or green is. Now probabilities have to add to 1. So the first thing I'm going to do is I'm going to add these probabilities up. So you've got 0.42, 0.3 and 0.18. Notice, because this is non-calculator, I'm using a written method to be accurate. So 2 plus 0 plus 8 is 10. 1 plus 1 plus 3, that's 5, plus 4 is 9, lining up our decimal point. So the total probabilities for blue, red and green are 0.9. We want the probability that it's not blue, red or green. So we're going to subtract that probability from 1, because probabilities add to 1. So 0 subtract 0, 0. 0 subtract 9, I can't do that and get a positive answer. So I'm going to borrow from here. 10 subtract 9 is 1. 0 subtract 0 is 0. So the probability that it's not blue, red or green is 0.10. Okay. I need to show that that bag must contain 10 balls. So I'm going to do 100 multiplied by 0.1, which is 0.10. Okay. So I'm going to multiply by 10. So I'm doing 100 times by 1, but then I need, which is 100. But then I need to reverse that multiplied by 10. So 100 divided by 10 is 10. So we've shown that it must contain 10 balls that are not blue, red or green. Question 16. Gary owns a garage selling second-hand cars. On Saturday he had 72 petrol cars and 48 diesel cars for sale. Part A. Write the number of petrol cars to the number of diesel cars as a ratio in its simplest form. Okay, so we're writing them in that order, guys. Petrol to diesel. Well, petrol is 72, diesel is 48. So I've got my starting ratio. That's going to get me a mark. Now I need to get it in its simplest form. Now I don't have a lot of space here, so what I am going to do is try and find my highest common factor of 72 and 48 to save myself a little bit of time. So factors of 72. We will have 1 and 72, 2 and 36, 3 and 24, 4 and 18, 5 dozen, 6 and 12. Okay, and then for 48, I'm going to do that here, guys. 1 and 48, 2 and 24, 3 and 16. But I'm going to stop there because I think my highest common factor is going to be 24 because they're just going to go down here. So I'm going to divide both of them by 24. So 72 is 24 times 3. 48 is 24 times 2. 3 and 2, the highest common factor is 1. So that is my ratio in its simplest form. Part B, what percentage of the cars are diesel? Okay. So let's see how many, actually let's work with our ratio. So we've got 3 to 2 in our ratio, which is petrol to diesel, okay? We're interested in what percentage of diesel cars there are. Well, 3 plus 2 is 5. So this ratio has a total of 5, but when I'm working with percentages, I want to work with a total of 100, okay? There are 25s in 100, so I would have scaled up by multiplying by 20. So I'm going to do the same to my ratio. 3 times 20 is 60. 2 times 20 is 40. I want the percentage of cars that are diesel. So this is 40 out of 100. Percentages are out of 100. So it's 40% of those cars are diesel. Question 17a. Calculate 12% of 750. Okay, so I'm going to build this up using different percentages. So I'm going to make 12% by finding 10%, 1% and 1% because 10 plus 1 plus 1 is my 12%. So 10% I divide by 10. So 750 divided by 10 equals 75. 1% I divide by 100. So 750 divided by 100 is 7.5. Notice how I'm making my life easier and I'm lining up my place value columns because I know I'm going to have to add these answers together to make 12% in total. And then again, 1% would be 750 divided by 100, which is 7.5. So I'm going to add these together. So 5 plus 5 is 10. So put the 0, carry the 1, decimal point in the correct place. 7 plus 7, 14. Plus 5, 19, plus 1 is 20. 2 plus 7 is 9. So 12% of 750 is 90. Now that makes sense to me because 12% is quite a low percentage when we're dealing with out of 100. So I would want a smaller number than 750. Part B, when a fraction is added to 2/5, so a fraction is added to 2/5, the answer is 7/15. Find the fraction that is added. So something plus 2/5 is 7/15. We're trying to find that something. Okay, guys, so we're going to do inverse operations. So the inverse of adding 2/5 would be to subtract 2/5. So we're going to do 7/15 subtract 2/5. Now, when we're adding or subtracting fractions, we need a common denominator. Now, this denominator is 15. This one is 5. 5 is a factor of 15. So I'm just going to scale up one of these fractions. So 7/15 is going to stay as it is, but 2/5 is going to get multiplied by 3 because 5 times 3 is 15, which gives me a common denominator of 15. But I have to do the same to the numerator to get an equivalent fraction so that we're balanced. So 2 times 3 is 6. So now I have a common denominator. Okay, so I can write this as a fraction. 7 subtract 6 for the numerators all over 15. Well, 7 subtract 6 is 1. So my answer is 1/15. So 1/15 plus 2/5 is equal to 7/15. Sarah has a water container in the shape of a cuboid. So we're working with a 3D shape. The area of the base of the container is 150 centimetres squared. So this is our cuboid. This is our container. The area of the base here is 150 centimetres squared. Water is leaking from the container at a constant rate. So that constant rate is important. That's going to help us with our calculations. At 10 o'clock, the water is 20 centimetres high. At 10:15, the water is 7 centimetres high. How much water is in the container at 11? Give your answer in litres. Okay, so it's leaking at a constant rate. So to find out how much water is in the container at 11, we need to be able to find the volume of the container with the water at 11 o'clock. So we're going to do the area of the base, which we have, multiplied by the height of the water. So let's look at this information here to start off with. Okay, so we're going to look. So at 10 o'clock, it's 20 centimetres. At 10:15, it's 7 centimetres. So in 15 minutes, it's gone down by 3 centimetres. So at 10:30, in another 15 minutes, it should go down by another 3 centimetres because we're working at a constant rate. So that would be 14 centimetres. And then at 10:45, let's go down by another 3 centimetres. So that would be 11 centimetres. We want to know how high the water is at 11 o'clock. So that's the next 15-minute interval even. So we're going to subtract 3 centimetres. So it's 8 centimetres. So the height of the water at 11 o'clock is 8 centimetres. So we need to find the volume of water that's included in there so that we can then say how many litres. I know what I'm talking about. So to find the volume of a prism, so a cuboid, a 3D shape, we do the area of the base, which is the cross section that runs through the shape. So 150. So this is us working with volume here, guys. Multiplied by the height. Well, the height at 11 o'clock is 8. So we're doing 150 multiplied by 8. So I'm going to do that calculation here. 8 times 0, 8 times 5, 8 times 1. So it's 1,200 centimetres cubed at 11 a.m. But we want to know how many litres of water there are in the container at 11 a.m. So we need to convert our centimetres cubed into litres. Okay, well, 1 centimetre cubed is 1 millilitre. There are 1,000 millilitres in 1 litre. So we need to divide this by 1,000. So 1,200 divided by 1,000 is 1.2. So there are 1.2 litres of water in the container at 11 o'clock. Question 19. 120 people each completed a puzzle. The times taken to complete the puzzle are shown in the diagram below. The diagram uses groups of width 5 minutes, so from 0 to 5, 5 to 10, 10 to 15, 15 to 20, 25 to 25, etc. So we've got the frequency, so the number of people, and then the time it took them to complete the puzzle. A person is chosen at random, so we're choosing a person out of the 120, so out of 120. Okay, what is the probability that this person took less than 15 minutes to complete the puzzle? Okay, so we're working out of 120 people in total, so we need to figure out how many took less than 15 minutes to complete the puzzle. So we're interested in these people, and these people, because that is less than 15 minutes. Okay, so let's read across here. So this is 40 people, this is 30 people, and this is 20 people. So 40 plus 30 plus 20, that's 70, that's 90. So 90 out of 120 people took less than 15 minutes to complete the puzzle. With probability, we don't have to simplify that fraction, so I'm just going to leave it like that. Question 20. The diagram below shows 3 straight lines, AB, CD and GH. Show that AB and CD are parallel. So we're trying to show that AB and CD are parallel. You must give reasons to justify your answer. So not only are we showing it with working out, we've got to give reasons as well, guys. Okay, so it tells us that these things are straight lines, so that's helpful for angle facts. Diagram not drawn to scale, so we're showing that these 2 lines are parallel. They don't look parallel because they look like they could potentially meet, however, not drawn to scale. So what we're going to do is we're going to find as many angles as possible as we can to then form some kind of relationship between AB and CD using angles in parallel lines. So we're looking at corresponding angles, co-interior angles, those kind of things, alternate angles. Right, let's start filling in some information then, shall we? So I'm going to say angle AEF. So angle AEF is 80 degrees because vertically opposite angles are equal. Remember, we've got to give our reasons. So vertically opposite angles is the angle fact that I use to recognise that that angle is 80. So I'm going to say AEF equals 80 because vertically opposite angles are equal. Okay. Now I'm going to see if that helps me. Well, it does actually. And this is only a 2-mark question, so we're not expecting lines of working out here, guys. Potentially 2 steps. And I think I can do this in 2 steps. So now I've got these co-interior angles. So if I think about this here, so AB and CD, if they're parallel, then these co-interior angles, the angles that are on the interior of the parallel lines when they're cut by this transversal, so co-interior angles must sum to 180. So I'm going to write that to start off with. Co-interior angles sum to 180 degrees. But I'm going to make it very clear that these 2 angles are the ones that I'm looking at. So angle AEF equals 80. Angle CFE equals 100. So when I add those together, 80 plus 100 equals 180. Therefore, co-interior. So AB and CD are parallel. Always finish it off with a final statement, guys. Question 21. David and Asif are studying the size of leaves. Before measuring the leaves, they agreed on the following conditions. The length of the leaf does not include the stem. The width of the leaf is measured at the widest part of the leaf. Part A. Why do they need to agree on these conditions to measure the leaves? Okay. So really, they need to agree on those conditions to make sure it's fair and they both measure the leaves in the same way. because we've got two people studying the size of leaves. If we don't put some conditions in, one of them might measure them differently to the other. So I would say a statement here to make sure they survey the size of leaves in the same way for consistency. Yeah, because if they both don't do it the same way, the data's not going to be consistent and it's going to tell us absolutely nothing. Part B, David and Asif have each drawn a scatter diagram to show their results. So we've got David's scatter diagram and we have Asif's scatter diagram. I need to move some things so I can show you both diagrams at once. There we go. Hopefully we can see those. Let me make it a little bit. Okay, wonderful. Let's work with that. So, B part 1, one of the boys collected all of his leaves from one tree. Okay, so one of the boys collected all of his leaves from one tree. Who was this most likely to be? And give a reason for your answer. Okay, so if we look at the graph, so David's scatter graph, the points are a little bit all over the place. Asif's scatter graph, his scatter diagram, the points are following a little bit more of a trend, so they seem to have a correlation. So we're going to say it's more than likely that Asif collected the leaves from one tree because we're looking at similar size leaves, whereas these are all a bit scattered. So we're going to say Asif, and we're going to say that Asif's results have, oh, I'm not writing very well here, guys, sorry, have a correlation. So they have a relationship, and we'd expect that if they were from the same tree. Part 2. Draw a line of best fit on Asif's scatter diagram. So we're just dealing with Asif's now. So let me get David's out of the way to make this a little bit clearer. Okay. So draw a line of best fit on Asif's scatter diagram. Now the thing with lines of best fit are, they need to follow the trend of the data, and a line of best fit gives us an average that we can predict from. Okay, so it needs to be roughly in the centre. Doesn't have to go through 0. It doesn't have to go through all the points, but we want to have roughly an equal amount of points on either side of our line of best fit. Don't join the points together. That's not what we're aiming for, guys. So we want to follow this positive trend, and we want to get roughly an equal amount on either side. It's a rough estimate. I am doing this, guys, with a pen so you can see it nice and clearly. Please do not do it with a pen. Do it with a pencil in case you want to rub it out and change where you put your line of best fit. Now, you'll be pleased to know, because the line of best fit is subjective to where our individual eyes tell us that the middle of that data would potentially be, there is a range that you can be within, so don't worry. Okay, there's an accuracy range. So as long as you're aiming for roughly in the middle, you should be good. And as long as you use your line of best fit that you've drawn for anything that follows, you will also be well. So we've drawn our line of best fit. Asif forgot to include the measurements of one of the leaves on his scatter diagram. The length of this leaf is 7 centimetres. Write down an estimate for the width of this leaf. Now, it's an estimate because we're using our line of best fit to predict here, guys. That's why we've drawn it, which is very useful. So we've got a length of 7 centimetres. We want to know its width. So we're going to go to our length. We're going to find where 7 centimetres would be. And now that we've drawn our line of best fit, we're going to draw a line across to our line. And then when it meets our line, we're going to draw it down to the width axis. And we're going to read off what that value is. Well, 6, that would be 7. So that's 7.2. So I estimate that the width of this leaf is 7.2 centimetres. And again, if your line of best fit is completely off whack, but you estimate correctly from the line that you've drawn, you're going to get this mark, you'll just lose this one. If your line of best fit is roughly okay and within a range, you're going to get this mark. But you need to show them that you're using your line of best fit, guys. Don't rub those lines out unless they're wrong and you want to do it again. Question 22. Ivy mixes lemon juice, pineapple juice and orange juice in the ratio 1 to 2 to 7 to make a fruit drink. So I'm just going to mark that ratio. So that's lemon juice, pineapple juice and orange juice, because the order it's written in is the order it's in the ratio, and I want to be aware of which part is which. Ivy has 330 ml of her fruit drink in a glass. How much pineapple juice is in Ivy's glass? So we're showing that 330 ml into this ratio, and we're interested in how much pineapple, so how much that middle value would be. So when we're sharing into a ratio, guys, we need to find the total number of parts in our ratio. So 1 plus 2 plus 7, 1, 2 and 7. So that's 10. There are 10 parts in total. We're going to divide the 330 ml of fruit drink by 10. So 330 divided by 10 is 33. So each one of these parts, so lemon, pineapple, orange, 1 to 2 to 7, each one part is worth 33. So I need to multiply each section of this ratio by 33. So lemon would be 33 ml, pineapple 2 times 33, which is 66, and then orange 7 times 33. Now you can work out 7 times 33 if you want to, but I'm not going to, because we're interested in how much pineapple juice is in her glass. So I'm just going to be interested in the pineapple column. I'm not going to mess around with 7 times 33 and hurt my brain. So there are 66 ml of pineapple juice in that glass of fruit drink. Question 23. The shape below consists of a square surrounded by 4 semicircles. So a square and then surrounded by 4 semicircles. The diameter of each semicircle is 12 centimetres. The diagram's not drawn to scale, so we need to note that we can't measure anything directly from it. Work out the area of the shape. Give your answer in the form a plus b pi. Now this is giving our answer in exact form, and this is helpful because this is a non-calculator paper, and usually when we're dealing with circles we'd press the pi button on our calculator, wouldn't we? But we don't need to. We're going to leave it in terms of pi. So we want the total area. So we want the area of the square, the area of the 4 semicircles, and we're going to add them together. So let's start with the area of the square. Now it tells us that the diameter of each semicircle is 12 centimetres. So the diameter is all the way across the middle there. So if the diameter is 12 centimetres, that tells us that the side of each square, each side of the square is also 12 centimetres. So the area of the square is 12 times 12, which is 140 centimetres squared. Okay, now we're going to deal with the area of the semicircles. So the area of a circle would be pi times radius squared. We know the diameter is 12, the radius is half of that, so the radius should be 6 centimetres. So the area of a full circle would be pi times 6 squared, the radius, which is 36 pi. Alright, we don't have full circles, but we have semicircles, but they're exactly the same, and 2 of those semicircles would make a full circle. So we've got 1 full circle, 2 full circles. So we've got 36 pi plus 36 pi, which is 72 pi centimetres squared. So the total area is our 104 centimetres squared plus our 72 pi centimetres square. Okay, so 144 plus 72 pi. Now let's double check what it is they wanted from us in terms of an answer, guys. Okay, they wanted it in the form a plus b pi. A is 144, b is 72, and our pi's there. So I'm just going to write that on my answer line. Question 24. Izan has a block of stainless steel with a volume of 700 centimetres cubed. The stainless steel has a density of 7.5 grams per centimetres cubed. Izan says the block has a mass of less than 5 kilograms. So he says it has a mass of less than 5 kilograms. Is he correct? Yes, no, or we cannot tell, and we have to show how we decide. We're not going to rush to tick any boxes here, guys. We're going to do some working out to show how we make our decision. So we're dealing with density mass and volume. So density is equal to mass divided by volume. You might use something similar to these formula triangles. You might have used them with SOHCAHTOA, speed, distance, time, force, pressure and area. We can use it with density, mass and volume as well. So we know that we have a volume of, I'm going to fill out this triangle. So we have a volume of 700. We have a density of 7.5. Izan says that we have a mass of less than 5. So let's work this out. Let's find the mass. So mass equals 7.5 times 700. Let's figure out what that is and see if we agree with him. Okay. So we've got a decimal multiplied by an integer. So I'm going to multiply this by 10. So I'm going to do 75 times 700 to start off with. I'm going to do my working out down here. Again, whatever method works for you. I always default to column method, but you could use grid method, chunking, whatever works. 5 times 0, 5 times 0, 5 times 7. I'm moving from the units to the tens, so I need a placeholder 0 there. 7 times 0, 7 times 0, 7 times 7. And then I'm going to add these two values together. So that's 0, 0, 5, 12, 5. So that equals 52,500. I multiplied by 10 to make my life easier. I need to reverse that, so I need to divide by 10. So that's 5,250. Okay, now we were working, if we look up here, in grams per centimetres cubed for the density. So the volumes in centimetres cubed are masses in grams. Izan says that it's got a mass of less than 5 kilograms. So we need to convert our 5,250 grams here into kilograms. So 1 kilogram is 1,000 grams. So 5,250 divided by 1,000 is 5.25 kilograms. Well, 5.25 kilograms is not less than 5 kilograms. So we're going to say that he's wrong. Question 25. Write 60 as a product of its prime factors in index form. So I'm going to do a prime factor tree, guys. So I'm going to start with 60 and I'm going to pick a pair of numbers that multiply to give me 60. So I'm going to go with 2 and 30. I'm going to check that pair of numbers now. Are any of them prime? Well, 2 is prime. So I'm going to circle that and it ends that branch. 30 is not prime because it has more than 2 factors, one in itself, so I need to continue the branch. 2 numbers that multiply to give me 30. Well, I'm going to go 3 and 10. Check those numbers now. 3 is prime, so that ends that branch. 10 is not prime because it has more than 2 factors, so we're going to continue that branch. 2 times 5, well, 2 is prime and 5 is prime. So we have our prime factors. Now, product of prime factors means we need to write it as a multiplication. Product is multiply. So we've got 2 times 3 times 2 times 5. It wants it in index form. So we need to write it in index form. So if I change the order of these, we can see we have 2 times 2. Well, in index form, 2 times 2 can be written as 2 squared. So we're going to write 2 squared times 3 times 5 on our answer line. Question 26. The diagram below shows an equilateral triangle. So you've got an equilateral triangle and a square. So we've got a square here and we've got some dimensions labelled on them. Diagrams are not drawn to scale, so we can't measure anything directly from them. Use an algebraic method to find the value of x and the value of y. You must show all your working out. Okay, and we've got to use algebra. They specifically say that. Okay, so my equilateral triangle only involves x, but my square involves x and y. So I'm going to start with my equilateral triangle to find the value of x, so then I can use that to help me when I get to the square. So equilateral triangle, well, what do we know about an equilateral triangle? All 3 sides are the same. So if that's the case, 2x add 3 is equal to 8. So let's form an equation. 2x add 3 is equal to 8, and we're going to solve for x. So we're going to get our x value. When we're solving equations, we use inverse operations. This is a two-step equation and we're aiming to isolate the variable x. So the first thing I'm going to do is eliminate my plus 3. The inverse of adding 3 is to subtract 3. So 2x and then 3 subtract 3 cancels that out for me, it eliminates it. But I need to do the same on both sides to balance the equation. So 8 subtract 3 is 5. Now we have a one-step equation. Remember, 2x is 2 multiplied by x. The inverse of multiplying by 2 would be to divide by 2. So 2x divided by 2 would give me x. I have isolated x, but I need to divide by 2 on the other side. So 5 divided by 2 is 5 over 2, which is 2.5. So now I know my x value. The first thing I'm going to do is go to the bottom here and write 2.5. Wonderful. Now we need to find y. So I know that x is 2.5 and the information about the square has y involved. So what do we know about the square? Well, we know on a square all of the sides are the same. So that tells us that 7x subtract 5y must be equal to 10. So we're going to form an equation. 7x subtract 5y must be equal to 10. However, we know that x is equal to 2.5. So we can substitute that x value in to that equation there. 7 times 2.5. Do this however you want to do it, guys. I'm going to do a quick multiplication. You might want to add 2.5 together 7 times. It's entirely up to you. I'm going to multiply that by 10. So I'm doing 7 times 25. 7 times 25. So 25 times 7. 7 times 5 is 35. 7 times 2 is 14. That's 17. So that's 175. I multiplied by 10. I need to reverse that. So that would be 17.5. So we have 17.5 subtract 5y equals 10. We're going to solve this two-step equation now. Okay, guys? So the first thing I'm going to do to try and isolate y is to eliminate the 17.5. It's positive 17.5. I know that because there's no negative sign. So the inverse of adding that positive 17.5 would be to subtract it. So when we subtract it from the left-hand side, that eliminates it. I'm left with minus 5y. That negative sign needs to stay there, guys. It doesn't disappear. It's attached to this 5. And then when I subtract 17.5 from this side, 10 subtract 17.5 is negative 7.5. Now, we're trying to isolate y. Negative 5y is negative 5 multiplied by y. The inverse of multiplying by negative 5 is to divide by negative 5. Negative 5y divided by negative 5 is y. We have to do it on the other side. So negative 7.5 divided by negative 5. Well, a negative divided by a negative is a positive. So we're doing 7.5 divided by 5. I'm going to get that into a decimal, guys. Easier for me to work with and put on my answer line. So I'm going to do 7.5 divided by 5 in bus stop method. So 5s into 7 is 1, remainder 2. I've got to match that decimal point. 5s into 25 is 5. So y equals 1.5. So I'm going to put 1.5 on my answer line. Question 27. Simplify 7 root 2 multiplied by 3. So when we're simplifying surds, when we're multiplying surds, we're going to do our coefficients, our integer numbers multiplied by each other. So 7 times 3 is 21. And then that root 2 is still there, guys. So the answer is 21 root 2. Question 28. Factorise 3xy squared add 6x squared y. So when we're factorising, we're aiming to pull out the highest common factor and have the remainder in a bracket. This one is just going to be one bracket. We might have squareds in there, but we need squared terms and coefficient number term, so a constant number term on its own, guys. We don't have that, so we're going to have one bracket, but we need to find the highest common factor. So what I'm going to do is I'm going to split these numbers up. So this could be written as 3 times x times y, and then 6x squared y could be written as 2 times 3, because that's my 6, times x times x times y. So x times x is my x squared, y is my y. So now we're going to identify what they have in common, okay? So they have 3 in common, x in common, and then a y in common. So 3xy is our highest common factor, so we're going to pull that on the outside of the brackets. And then anything that's left with both numbers is what goes on the inside of the brackets. So for 3xy squared, we simply have y left. So we're going to put y in the bracket, plus, and then for 6x squared, we have 2 and x. So we have 2x left, so we're going to put 2x and close the bracket. Question 29. Hans thinks of a number. When his number is multiplied by 2.4 times 10 to the power of 5, the answer is 9.6 times 10 to the power of 8. What number did Hans think of? Write your answer in standard form. So what we've done is we had a number, we multiplied it by 2.4 times 10 to the power of 5, and that gave us 9.6 times 10 to the power of 8 as an answer. We need to find that missing answer, so we're going to do the inverse. Instead of multiplying, we're going to divide. So we're going to do 9.6 times 10 to the power 8 divided, I'm going to write it as a fraction and you'll see why shortly, divided by 2.4 times 10 to the power of 5. So we're reversing it to find that missing number. Now the reason why I've written it as a fraction is to make our life a little bit easier. So we're going to do 9.6 divided by 2.4. Okay, and then we're going to do 10 to the power of 8 divided by 10 to the power of 5, and we're going to use our laws of indices, our division rule. So let's start with 9.6 divided by 2.4. However you want to do this, I think I'm just going to count up in 2.4s, guys, to be honest. So 2.4 plus 2.4, so that's 4.8, plus 2.4, so that's 7.2, plus 2.4, so that's 9.6. Okay, so we have got 1, 2, 3, 4 of them. So 9.6 divided by 2.4 is 4. Now we've got 10 to the power of 8 divided by 10 to the power of 5. The law of division for indices tells us if we have the same base and we're dividing, we can subtract the powers. So that's going to be times 10 to the power of 8 subtract 5, which is 3. Wants our answer in standard form, so we need to check. For an answer to be in standard form, this first number here needs to be between 1 and 10 and then multiplied by 10 to a power. 4 is between 1 and 10, so we can leave that as our final answer. Question 30. Kate is visiting London. The probability that she will go on a train is 0.4. The probability of Kate going to the theatre is independent of her going on a train. So whether she goes to theatre or not is not impacted by whether or not she takes a train, okay? The probability that she goes on a train and goes to the theatre is 0.28. Complete the following tree diagram in part A. Okay, so let's start with this first branch. So whether or not Kate goes on a train. So remember, probabilities sum to 1, and this set of branches has to sum to 1. So 1 subtract 0.4 is 0.6. So there's a 0.6 probability that Kate does not go on the train. Okay. The probability that she goes on the train and goes to the theatre is 0.28. So 0.4 times by something would give us 0.28 as a probability. So we need to reverse that. So we're going to do 0.28 divided by 0.4. The inverse of multiplying is to divide. Now I'm going to make my life a little bit easier. So I'm going to times this by 100 to make 28. And because I'm dividing, I've got to times this by 100 too, which makes 40. Okay, I can work with that. 28 divided by 40. If I write that as a fraction, so that's 14 over 20. I want it as a decimal, so I want it to be out of 100 so that I can easily convert it to a decimal. So I would multiply by 5. There are 5 20s in 100. So 14 times 5. 10 times 5 is 50. 4 times 5 is 20. So that's 70. So this is 0.7. Okay. So the probability that Kate goes to the theatre is 0.7. Now, these probabilities are independent of each other, so it would be 0.7 down here as well. Okay. Probability that she does not go to the theatre, well, probabilities sum to 1. So 1 subtract 0.7 is 0.3. So the probability of not going is 0.3. And we've completed our tree diagram. Part B. Calculate the probability that Kate does not go on a train and does not go to the theatre. So does not go on a train and does not go to the theatre. So we're going to do 0.6 and 0.3. We're following this branch, and when we're moving along branches on a tree diagram, we multiply. So 0.6 multiplied by 0.3. So what we're going to do here is make life a little bit easier. I'm going to multiply by 10 to make that 6, multiply by 10 to make that 3. 6 times 3 is 18, but I've got to reverse those multiplied by 10s. So I need to divide by 10, which is 1.8, but then I've got to divide by that 10 as well, which is 0.18. So 0.18 is the probability that Kate does not go on a train and does not go to the theatre. Question 31. Show that the lines 3y subtract 12x equals 9 and 2y equals 8x subtract 13 are parallel to each other. So for lines to be parallel to each other, they have to have the same gradient. So I'm going to rearrange both of these things to be in the form y equals mx plus c, because then I can compare the m's, because that's the gradient and I want those to be the same. Okay, I want them to be the same so that I can show that they're parallel. So let's start with this one. So we have 3y minus 12x equals 9. So I'm going to add 12x, because what I want to do is I want to get the y on the left hand side, everything else on the right hand side. So I'm going to add 12x. That gives me 3y equals 12x plus 9. But I need it to be y equals, so I need to isolate the y. At the moment it's 3 times y. So I'm going to divide by 3. So that would be y equals, and when I divide by 3, 12x divided by 3 is 4x, 9 divided by 3 is 3. So the gradient here for this one is 4. I'm going to do the same with this equation. So we have 2y equals 8x subtract 13. I've already isolated the term with y in, but I want it to be y equals. So the inverse of multiplying by 2 is to divide by 2. So when I divide by 2 on the right hand side, 8x divided by 2 is 4x. 13 divided by 2 I'm going to write as minus 13 over 2, because that's not what I'm interested in. I'm interested in comparing the coefficient of the x, because that's the gradient. So we've got to show that they are parallel to each other. So I'm going to write same gradient, so parallel. Question 32. It takes 2 hours to empty 8 identical tanks of water using 9 identical pumps. How long would it take to empty 2 of these tanks using 3 of these pumps? So I'm going to organise my information into a table. We know that I like tables. I like to work with these just because I can get really messy. You'll have seen watching my videos that I can get messy. So let's have the number of pumps, the number of tanks, and then the time it takes in hours. Okay, so 2 hours, 8 tanks, 9 pumps. We want to know how long it's going to take to empty 2 tanks with 3 of these pumps. So we're aiming for this time here. Okay. Now, what's happening here is the number of pumps is decreasing, but the time is going to increase, because if there's less pumps emptying those tanks, it's going to take longer. So we're dealing with inverse proportion here. Okay, so what I'm going to do first off is I'm going to find out how long it would take 3 pumps to do those 8 tanks. So I've got a comparison, guys. Okay, so to get from 9 pumps to 3, I'm dividing by 3, but the time's going to take longer. So the pumps have decreased, but the time is going to increase. So I'm multiplying by 3. So it would take those 3 pumps 6 hours to fill those 8 tanks. but I'm interested in how long it takes those 3 pumps to fill 2 tanks. Okay, so to go from 8 to 2, I would divide by 4. So I need to divide the time by 4. So this was an inverse proportion relationship, but this is a direct proportion relationship. If I'm filling 8 tanks for 6 hours, filling 2 tanks is going to take these three people less time, isn't it? So we're going to divide by 4. So we're going to do 6 divided by 4. Well, 6 divided by 4, I can simplify that as 3 over 2, which I know is 1.5. So it's going to take 1.5 hours for 3 pumps to empty 2 tanks.